There is a periscope sitting in a storage room at the U.S. Army Ordnance Museum. It is made of metal and glass, roughly the size of a thick book, and it looks like nothing special. No one stops to look at it. Most visitors walk past without a glance. But this object, the M6 periscope, standard equipment in every American Sherman tank during World War II, could see through smoke and haze and darkness with a clarity that German tank crews, peering through their own optics, sometimes could not match. And the knowledge that made this precision possible did not originate in the United States. It originated in a small city in central Germany, in a factory founded by a man who believed that optical science could be perfected the way any other science could be perfected, through mathematics, chemistry, and obsessive measurement. The city was Jena. The man was Carl Zeiss. And in 1907, the company bearing his name made a decision that would, across the span of 2 world wars, transfer the foundations of German optical dominance into American hands, and leave Germany fighting the Second War with a strategic disadvantage it could never fully overcome. This is a story about glass, about what it means to see clearly at a distance, and about how a business partnership, undone by one war, reconstructed between the wars, and ultimately outlawed by the second, became one of the most consequential technology transfers in military history. To understand what happened in 1907, you have to understand what Carl Zeiss represented, not just commercially, but scientifically. By the early 1900s, the Carl Zeiss Optical Works in Jena, Germany, had achieved something approaching a monopoly on precision optical glass for the entire industrialized world. By 1912, Germany was annually exporting nearly 176,400 kilograms of optical glass, with more than 25% going to Britain and the United States alone. This was not ordinary glass. It was glass manufactured to exact chemical formulas, different refractive indices for different military applications, each formula jealously guarded inside the Jena factory. The foundation of Zeiss's dominance was a collaboration between 3 men in the late 19th century: Carl Zeiss himself, the physicist Ernst Abbe, and the chemist Otto Schott. Zeiss built the instruments. Abbe developed the mathematical theory that told glassmakers exactly what optical properties they needed to achieve, and Schott, working from Abbe's specifications, figured out how to cook those properties into glass by adding specific amounts of barium, boron, and lead to the melt. Together, they created the Schott Glass Catalog, a library of precisely characterized optical glasses that became the international standard for anyone making lenses for military or scientific use. The development of the Jena glasses sparked a wave of innovation across optical design, and its impact on military ordnance was indelible. Conflicts in the mid-19th century had relied on sighting by eye, as weapons could fire only across relatively short distances, but steady increases in the range and accuracy of field guns and artillery had made high-quality optics an essential element in waging war. By 1900, a military without Zeiss glass was a military that was, effectively, half-blind. Rangefinders, the instruments that calculated the distance to a target so artillery could be aimed accurately, required optical glass of specific types and tolerances that only the Jena factory could reliably produce. The same was true of binoculars, periscopes, gun sights, and the increasingly important aerial photography lenses being fitted to reconnaissance aircraft. Germany understood what it had, and for a time it was happy to sell to the world. The Bausch and Lomb Optical Company was founded in 1853 by 2 German immigrants, John Jacob Bausch and Henry Lomb, in Rochester, New York. Bausch had come from Württemberg, Germany, had apprenticed in a Swiss optical shop, and arrived in America with little more than his training. Lomb was a cabinet maker from Hesse-Kassel who loaned Bausch $60, worth roughly $1,750 in today's money, in exchange for an equal partnership if the business ever turned a profit. They shook hands. No contract was signed. The business nearly failed several times in its early years, But the Bausch family possessed a critical talent. They could manufacture things. In 1878, Edward Bausch, son of the founder, learned to make microscopes, and the company began to grow. By 1890, Bausch and Lomb was producing photographic lenses, microtomes, binoculars, and telescope eyepieces, and had become the most capable optical manufacturer in the United States, which was still far behind Germany. In 1890, Edward Bausch contacted Carl Zeiss and soon arranged for Bausch and Lomb to license Zeiss's patents with exclusive rights to the U.S. market. The most important patents covered Zeiss's new photographic lens and its first prism binoculars. This early licensing deal was valuable to both sides. Zeiss got American manufacturing and market access without having to build a factory in the United States. Bausch and Lomb got access to technology that was years ahead of anything it could have developed independently. The relationship deepened through the 1990s and into the early 1900s. The practical result of this union was that every invention or improvement made either by Zeiss or by Bausch and Lomb was at once available to the other. The free interchange of ideas and methods was an advantage to each center of progress. Bausch and Lomb technicians were sent to Jena for training in Zeiss laboratories. German engineers visited Rochester. The knowledge flowed in both directions, but in the early years, it flowed predominantly westward, from Jena to New York. The formal deepening of this partnership came in 1907, and it had a specific commercial trigger: rangefinders. In the early 1900s, Zeiss perfected the military rangefinder. Impressed by U.S. manufacturing expertise, Zeiss eventually decided that rather than build its own factory, it would allow Bausch and Lomb to manufacture rangefinders in the United States. In 1907, Zeiss bought 20% of Bausch and Lomb, granting the company free use of Zeiss patents in the United States. The following year, the arrangement was formalized into what the two companies called the Triple Alliance. Zeiss bought about 33% of the Bausch-Lomb Segmüller Company, a temporary corporate name after a merger with another optical firm, and in January 1908, a corporate alliance was formalized. It was known as the Triple Alliance, and the new logo featured 3 prisms, each with the initials of the participating entities: BL, Z, and S. This was not a simple licensing agreement. This was an equity partnership. Zeiss owned a substantial stake in Bausch and Lomb. It was paid in dividends, not royalties. Zeiss engineers visited Rochester. B&L engineers visited Jena. The glass formulas, the lens designs, the manufacturing techniques, all of it passed between the two companies as a matter of routine business operation. Bausch and Lomb also sent technicians to Germany for training at Zeiss laboratories. Military products accounted for only a small amount of Bausch and Lomb's production, but as the only U.S. manufacturer of many optical products, production was nevertheless vital to the U.S. military. As a result, the U.S. Navy stationed technical experts in the company's plant in 1912. The U.S. Navy had already recognized what the alliance meant. Bausch and Lomb, armed with Zeiss knowledge, was the only institution in the Western Hemisphere capable of making the precision optical instruments the military needed. The Navy did not want to be surprised, so it embedded its own people inside the factory, keeping watch over the technology that would matter most if war ever came. The alliance lasted 7 years in its full form before the First War ended it. When Germany went to war in August 1914, the Allied powers discovered, with immediate and panicked urgency, that they had no ability to manufacture the precision optical glass their armies required. Britain had sourced the majority of its pre-war optical glass from Carl Zeiss AG, and by early 1915 was suffering from a shortage. The First World War was the first major conflict where more gun-laying was made by optical equipment such as binoculars and rangefinders than by unaided eye. These tools were essential for the accurate fire control of artillery pieces now shooting at ranges of up to 40,000 to 60,000 yards. The crisis was severe enough that Britain actually attempted to negotiate the secret purchase of optical instruments from Germany through Swiss intermediaries in 1915, an extraordinary episode in which enemies briefly conducted covert trade in the middle of a war, offering rubber in exchange for binoculars and gun sights. British troops were killed in terrifying numbers by German snipers using Zeiss scopes in the opening months of the war, while British officers were sometimes peering at those same snipers through identical Zeiss-built binoculars they had imported before the war. Bausch and Lomb saw the need immediately and made a choice. World War I put an end to the collaboration. In November 1915, after the war had been declared between Germany and the Allies, but before America entered the war, Zeiss withdrew from the corporate alliance on the grounds that Bausch and Lomb had furnished military instruments to Great Britain, which was not one of Bausch and Lomb's contracted markets. This was the fracture. Bausch and Lomb had sold binoculars, periscopes, gun sights, and searchlight mirrors to the British military, helping equip an army fighting against Germany, while technically still being a company with German equity and German patents. Zeiss was furious. It sold its shares back to Bausch and Lomb and severed the relationship. But Bausch and Lomb kept the knowledge. Beginning in World War I, Bausch and Lomb shared German knowledge with the American government and military, enabling the U.S. to combat Germany. Business interests and loyalty to America were clearly more important than the partnership with Zeiss. And then something happened that secured the American position for the next generation. When the United States entered the war in April 1917, the country faced its own optical glass crisis, far more severe than even the British had faced. At the time, optical companies in the U.S. were producing an estimated 2,000 pounds of optical glass per month, and what was being produced was done largely on a trial-and-error basis, which led most glass produced to be of inferior quality. Bausch and Lomb led the response. Its engineers reverse-engineered the Zeiss glass formulas they had learned during the Alliance years, combined them with new research, and scaled up production with extraordinary speed. After careful study of German samples and implementation of the scientific process, Bausch and Lomb was able to make 20,000 pounds of glass per month by November 1917, just 7 months after the U.S. had entered the war. That tenfold increase in production capacity in 7 months was only possible because of the technology Bausch and Lomb had absorbed during the alliance. The knowledge that Zeiss had transferred between 1907 and 1915 was now being used at industrial scale against Germany. After World War I ended in 1918, the global optical industry reached a strange equilibrium. Britain had built a glass industry from scratch. Germany had survived. The United States had Bausch and Lomb. But here is the detail that made the next war possible. After the war, the other U.S. companies that had learned to make optical glass stopped production, making Bausch and Lomb the only producer of scientific precision glass in the Western Hemisphere. Think about what this means. Spencer Lens, Pittsburgh Plate Glass, and other companies had all ramped up production during the war. When the war ended, the contracts ended, the money dried up, and one by one, they shut down their optical glass operations. The knowledge dispersed. The machinery went idle. Only Bausch and Lomb kept its glass plant running. By 1938, the company's own annual report stated a fact that should astonish anyone who reads it. Bausch and Lomb operates the only glass plant in America devoted exclusively to the manufacture of optical glass. A single factory in Rochester, New York, for an entire hemisphere. And then, in 1921, Zeiss came back. In 1921, Zeiss made all of its military patents exclusively available to Bausch and Lomb for use in the United States. The commercial logic was simple. Zeiss needed the American market, and Bausch and Lomb was the only American company capable of manufacturing to Zeiss standards. The partnership resumed, less formally than the Triple Alliance, but structurally very similar. The technology transfer continued. The Zeiss glass catalog continued to flow into Rochester. In the 1930s, military products represented 70% of total production at Bausch and Lomb. The company had transformed from a manufacturer of eyeglasses and microscopes into, in effect, the optical armory of the United States. Binoculars, rangefinders, gun sights, periscopes, camera lenses, all built in Rochester, all using techniques and formulas rooted in the Jenna catalog. By the late 1930s, Bausch and Lomb saw what was coming. As Europe once again headed toward war, Bausch and Lomb focused on becoming self-sufficient by searching for U.S. sources of most materials to make optical glass and by stockpiling 2 years' worth of foreign supplies. The divorce from Zeiss this time would be legal rather than political. In 1940, the U.S. Justice Department charged both companies with antitrust violations because of their agreed-upon division of world markets. The government alleged this resulted in inflated prices and questioned the propriety of a German company dictating the sales of optical products by a U.S. company. While denying any wrongdoing, Bausch and Lomb paid a fine and again severed its relationship with Zeiss. The partnership was over for the second and final time, but Bausch and Lomb once again kept everything it had learned. When the United States entered World War II in December 1941, the optical situation was as different from 1917 as it is possible to imagine. There was no scramble for glass formulas, no desperate reverse engineering, no months of catch-up production. Bausch and Lomb was ready. Because of the world wars and the consequent need for optical instruments such as field glasses, rangefinders, camera lenses, binocular telescopes, searchlight mirrors, torpedo tube sights, and periscopes, the product range could be considerably broadened. The Rochester factory scaled up immediately to a wartime footing, and the single most critical fact that Bausch and Lomb was the only precision optical glass manufacturer in the Western Hemisphere now meant that every optical instrument used by American, Canadian, British, and Allied forces in the Western theater depended on glass melted and cast in Rochester. That glass went into rangefinders on destroyers and cruisers, calculating the distance to enemy ships with the precision that allowed naval gunners to land shells accurately at ranges of 15 miles. It went into the periscopes of American submarines, instruments that allowed commanders to observe the surface from depth, identify targets, and direct torpedoes with the accuracy that made the Pacific submarine campaign one of the most devastatingly effective in naval history. It went into the tank periscopes. The M6 periscope, the small book-sized instrument mentioned at the beginning of this video, was installed throughout American armored vehicles. The Sherman and Stuart tanks used multiple M6 periscopes each, installed throughout the crew compartment to give different crew members visibility without exposing their bodies to enemy fire. The optical quality of these instruments, the clarity, the contrast, the ability to pick out a camouflaged enemy vehicle at distance, was a direct descendant of the Zeiss manufacturing principles absorbed by Bausch and Lomb during 30 years of partnership. During World War II, Bausch and Lomb produced optical instruments including rangefinders and field scopes. As one of the earliest manufacturers of high-quality sunglasses, the company also benefited from the use of Ray-Ban sunglasses by U.S. Army Air Corps pilots and General Douglas MacArthur. That last detail, the sunglasses, is worth pausing on, because it connects the Zeiss inheritance to one of the most recognizable objects of the 20th century. The Ray-Ban aviator sunglasses were not designed to be stylish. They were designed to solve a technical problem. In 1929, U.S. Army Air Corps Colonel John A. McCready worked with Bausch and Lomb to create aviation sunglasses that would reduce the distraction for pilots caused by the intense blue and white hues of the sky. Specifically, McCready was concerned that pilots' goggles would fog up, greatly reducing visibility at high altitude. The prototype, created in 1936 and known as anti-glare, had plastic frames and green lenses that could cut out the glare without obscuring vision. The name Ray-Ban was derived from the ability of these glasses to limit the ingress of ultraviolet and infrared rays of light. The green mineral glass used in those lenses, chosen for its specific transmission curve across the visible spectrum, was a product of the same optical glass tradition that Zeiss had built in Jena. The precise filtering of specific wavelengths, the ability to manufacture glass with repeatable and predictable spectral properties, these were skills Bausch and Lomb had learned from the Zeiss partnership and refined in its own Rochester laboratory over decades. During the second half of the 1930s and early 1940s, Ray-Ban aviators became standard issue for U.S. military pilots. The military flying sunglasses were standardized in November 1941, produced in huge quantities for pilots and sailors. The U.S. government specified the shape and the color of the lens, and various contractors, including American Optical, Bausch and Lomb, and others, made the frames and ground the lenses. The image of General Douglas MacArthur landing on the beaches of the Philippines in October 1944 wearing his aviator sunglasses, a photograph reproduced in newspapers across America and instantly recognized as one of the defining images of the Pacific War, was, in a narrow technical sense, a photograph of Zeiss optical heritage being worn by the commander of the forces that were dismantling Japanese power in the Pacific. The technology had come a long way from Jena. To understand the military significance of the optical advantage, you have to understand what a rangefinder actually does in tank combat, and why the Americans, equipped with Bausch and Lomb optics rooted in Zeiss science, were able to see what the Germans, using Zeiss optics directly, sometimes could not. The paradox sounds impossible, so it requires explanation. Germany went to war in 1939 with Carl Zeiss still operating in Jena, still producing the finest optical glass in the world, still equipping the Wehrmacht with binoculars and gun sights of superb quality. The early years of German tank combat were dominated by optical superiority. German commanders, with their head-out-of-the-hatch leadership style and their superior early optics, made decisions faster and more accurately than Allied tank crews. This advantage was real and substantial in 1939 and 1940. But war is an industrial competition as much as it is a tactical one, and by 1942, the industrial mathematics had shifted decisively against Germany. Here is the central supply problem Germany could not solve. The Zeiss factory in Jena was one factory. It could be bombed, it could be overwhelmed by demand, it could not simultaneously supply the optics for tens of thousands of tanks, hundreds of ships, thousands of artillery batteries, and the Luftwaffe's reconnaissance and bombing aircraft, all of which required different types of precision optical glass, and all of which were being produced in rapidly escalating numbers. By the late war, German production of optical glass was itself failing to keep up with high demand from the army. Despite expansion programs in 1914 and 1915 that increased the Zeiss workforce from 5,200 to 9,800 persons, the government was forced to intervene to allow other companies into the market, and by the late war, shortages of glass instruments were apparent. This pattern from World War I repeated itself with far more devastating consequences in World War II. Germany had one center of optical excellence. America had Bausch and Lomb, the only precision glass plant in the Western Hemisphere, operating at full wartime scale, undisturbed by bombing, fed by American industrial capacity, and building on 40 years of accumulated Zeiss-derived knowledge. The production asymmetry was catastrophic for Germany. The Wehrmacht could design excellent optics, the gun sights on the Panther and Tiger tanks were technically superb instruments, but it could not produce them in the numbers required. Supply failures meant German tank crews sometimes went into combat with substandard or damaged optics that had not been replaced. Range estimation accuracy declined. Hits at distance became harder. American tank crews, by contrast, had the M6 periscopes and telescopic gun sights that the Rochester factory was producing in massive quantities, every instrument consistent, every piece of glass ground to specification, every instrument ready to operate the moment it came out of the crate. The title of this video states a deliberate provocation that Germany lost every tank battle because of Zeiss's 1907 decision. This is, of course, an overstatement in the tactical sense. German armor inflicted tremendous casualties throughout the war, and individual engagements were decided by many factors. But in the industrial sense, in the sense of whether Germany's optical manufacturing capacity could sustain a global war against a nation that had inherited, absorbed, and industrialized German optical science, the statement is closer to the truth than it might first appear. The decision to share the Zeiss lens secrets with Bausch and Lomb in 1907 created an American optical industry that 35 years later could outlast Germany's own. To make the human scale of this story concrete, consider the chain that runs from the Zeiss factory in Jena to a specific moment in 1944. A U.S. Navy destroyer operating in the Philippine Sea is tracking a Japanese vessel. The rangefinder operator, a young sailor from Ohio who has never been to Germany and has likely never heard of Carl Zeiss, presses his eyes to the eyepiece of an instrument he has been trained to operate. The rangefinder calculates distance by measuring parallax between two lenses separated by a fixed baseline. The calculation is only as accurate as the glass in those lenses, their freedom from bubbles, from striae, from irregularities that would distort the light path and introduce error into the measurement. The glass in the lenses came from Rochester. It was manufactured by Bausch and Lomb using formulas and processes that trace their lineage directly to the shot glass catalog and the Zeiss manufacturing techniques absorbed during the Triple Alliance. The sailor hits his target. Or consider the submarine periscope. A U.S. submarine is operating in the Luzon Strait, one of the most dangerous convoy routes in the Pacific. The commanding officer takes a bearing, makes a range estimate, calculates the torpedo firing solution. The periscope through which he is observing must deliver a sharp, undistorted image at multiple magnification settings. The clarity of the view determines whether his range estimate is accurate enough to guide the torpedo to its target. That periscope's glass came from Rochester. The techniques that allowed Bausch and Lomb to grind glass to those tolerances came from Jena. Or consider the tank gunner in Tunisia or Normandy, looking through his telescopic sight as he traverses the turret to track a moving target. The sight must hold at zero, the relationship between the point of aim and the point of impact across extremes of temperature and vibration. The glass must transmit maximum light in the dusty, smoke-obscured conditions of the battlefield. That sight was made in Rochester, New York, in a factory that had been trained by the finest optical engineers in Germany. The knowledge had crossed the Atlantic and been turned against its source. The most direct living descendant of this story is the pair of sunglasses you might have in your car's center console, or on your nightstand, or pushed up on your head at this moment. Ray-Ban was created by Bausch and Lomb in 1936. In 1999, Bausch and Lomb sold the brand to Italian eyewear conglomerate Luxottica Group for a reported $640 million. The company that bought it no longer has any connection to the German optical tradition. The current product is manufactured under entirely different conditions with entirely different materials. But the original Ray-Ban aviator, the one that General MacArthur wore on the beach at Leyte Gulf, the one that test pilots wore at Muroc Army Airfield in the 1940s, the one that became one of the most imitated sunglass designs in the world, was made from optical glass ground in a factory whose techniques came from Zeiss. The green mineral glass, the transmission curve, the precision of the lens geometry, these were the products of a technology transfer that began in 1892 and reached its formal peak in 1907. There is also a contemporary parallel that may be obvious by now, and it is worth making explicit because this is a channel that connects historical events to modern relevance. The story of Zeiss and Bausch and Lomb is a story about what happens when a nation transfers its most advanced technology to a foreign company for commercial reasons and then finds that technology turned against it in a conflict. The Zeiss leadership of 1907 could not have foreseen either world war, could not have anticipated that their American partner would use German optical knowledge to equip British troops fighting Germany, and could not have known that the Western Hemisphere's only precision optical glass plant would belong to a company they had created. Technology transfers are always made in the context of a present that cannot fully anticipate the future. The Zeiss engineers and executives who built the Triple Alliance were not reckless or naive. They were making a perfectly rational business decision in 1907 in a world where Germany dominated optical science, and the United States was an eager, capable manufacturing partner. The catastrophic consequences of that decision were visible only in retrospect, only after 2 wars had passed through the transfer and turned it into something its architects could not have recognized. The optical glass Bausch and Lomb made in 1944, the glass that went into the rangefinders and periscopes and gun sights used against Germany, had its roots in the Schott catalog and the Zeiss laboratory. The knowledge had traveled from Jena to Rochester, been absorbed and industrialized, and returned across the Atlantic in the form of weapons. After World War II ended, Bausch and Lomb remained what it had become, the dominant optical technology company in the Western Hemisphere. During the war, the percentage of company output relating to the military soared, but by the early 1950s, military sales had fallen to 15% of the total. Sales had increased to about $48.5 million, and the firm had more than 150 prescription labs for grinding and polishing glass lenses throughout the United States. The glass technology that had been built during the war, the formulas, the melting procedures, the annealing protocols, the precision grinding techniques, was the foundation of American optical science for the next generation. It trained the workforce that would later build the cameras mounted on satellites and the optics in reconnaissance aircraft. 3 Bausch and Lomb Super Baltar lenses were aboard the Ranger 7 spacecraft when it photographed the Moon in 1964, sending back humanity's first close images of the lunar surface before the craft impacted. The company's Cine4 projection lenses, developed in the late 1930s and used by almost all American movie theaters, were good enough to win Bausch and Lomb an honorary Academy Award. The contact lens industry, which Bausch and Lomb pioneered and which now serves hundreds of millions of people worldwide, was built on the optical glass expertise accumulated over 50 years of Zeiss partnership and 2 world wars of production. John Jacob Bausch and Henry Lomb arrived in Rochester in 1849. They were German immigrants with no money, no connections, and no particular reason to believe their small optical shop would survive. Within a generation, their company had become the American conduit for the finest optical science in the world. Within 2 generations, it had turned that science into an industrial capability that helped defeat the country whose scientists had built it. There is a part of this history that almost no one talks about, and it is the part that matters most to the present moment. Bausch and Lomb's glass plant, the only precision optical glass manufacturer in the Western Hemisphere, the plant that had won 2 world wars, closed in July 1985. 70 years of accumulated expertise gone. The equipment was sold or scrapped, the workforce dispersed. The formulas survived in archives, but the institutional knowledge, the tacit understanding of how to melt a specific glass, how to anneal it without introducing stress, how to control the variables in a furnace to achieve a specific refractive index, that knowledge exists now only in documents and in the memories of a generation of engineers who have mostly retired. The United States today has no major domestic producer of the type of precision optical glass that Bausch and Lomb used to make. That capability has moved to Germany, to Schott AG in Mainz, to CDGM in China, to a handful of other international suppliers. American military optics today are built from glass that comes largely from overseas. This is not necessarily catastrophic in peacetime. Trade works, supply chains function. But the Zeiss Bausch and Lomb story is a reminder of what happens to those supply chains when the political context changes, when a company that is a commercial partner in 1907 becomes a military adversary in 1917, or when a business relationship that seems mutually beneficial in peacetime becomes a strategic vulnerability in war. Germany gave Zeiss lens secrets to one American company. That company spent 30 years learning them, built a single glass factory in Rochester, and emerged from the Second World War as the optical arsenal of the democratic world. The glass factory is gone. The lesson is not.